Hi class, welcome to lesson 65. In this lesson, we are going to learn to identify functional groups and name substituted hydrocarbons. That means these hydrocarbons will have different elements in addition to carbon and hydrogen. Now, the most important part of this lesson is that this should not be an exercise in memorization, but instead, we are going to use our reference table to find patterns. So all functional groups can be found on reference table R. Make sure you have your reference table with you today and you're following along. Again, we are not memorizing any of this. Instead, we are going to look for patterns on the reference table and use those patterns to identify functional group or substituted hydrocarbon. So again, when we're naming or drawing these substituted hydrocarbons, you're going to look for the example on table R and compare it to your problem. First, you want to find the class of the compound and see how it is named, or draw the example. And then what you want to do is model or draw your example to meet this pattern. So let's do some of these together. So again, this is not memorization. You're using reference table R. So when we look at the first compound, we can see the halides or halocarbons, and they have one or more halogens attached. So in the Regents example, the name is called 2-chloropropane. So when we go and we count the carbons and hydrogens in the structure, you can see here I've numbered the carbons. So there's 3 carbons, giving this prefix prop. These are singly bonded carbons, so it's propane. And what we're going to do is we're going to draw the chlorine on the second carbon because the number 2 tells us that that's the location of the halogen. So here we have 2-chloropropane. Now let's see if we can name this example. So here in this example, we're going to start by counting on the parent chain. I can see that there are 3 carbons and they're all singly bonded. So we're going to call that prop, and the suffix is ane for the single bond. So this is propane as well, but this here, we have fluorine attached. So we see that fluorine is called fluoro. So this should be fluoropropane. And this fluorine is on the second carbon. So this is 2-fluoropropane. Similar to other substituted groups, if we have more than one, we can use prefixes like di, tri, etc. So here we can see that we have the substituted group bromine, and we have 1 bromine on the first carbon and 1 bromine on the second carbon of this ethane molecule. This would be called 1,2-dibromoethane. Here's another functional group, alcohols. We discussed alcohols very briefly during our look at acids and bases because alcohols end in OH but are not bases. So we always know that if a substance starts with carbon in its molecular formula and ends in OH, it's never a base. It actually could be an acid, and we should check our reference table, or it could be an alcohol. So alcohols have OH groups and they end in OL. And you can see from the example here, 1-propanol, that we know that there's a special group. The alcohol group is on the first carbon of a 3-carbon chain structure. So let's take a minute to look at this alcohol. So the first thing we notice is we have an OH group. And here we have to figure out how many carbons are in the parent chain and which carbon this is attached to. So here there are 4 carbons. And if I number from left to right, this alcohol group is on the fourth carbon. If I number the chain from left to right, this OH group is on the first carbon. So since 1 is less than 4, we're going to call this 1 bute because there are 4 carbons, enol. So here we have 1 butanol. Here we're going to look at ethers. Ethers have the O, which always forms 2 bonds, but the O is included between 2 carbon chains. So for ethers, we name the carbon chains separately. So the Regents example gives us methyl ethyl ether. So we can see that methyl means 1 carbon. And so we have a 1 carbon chain on the left, and the oxygen splits it from a 2 carbon chain on the right. So let's look here at this example. So here we have an ether. We can see the included oxygen, and we have a methyl group on the left and a methyl group on the right. So this structure could be called methyl-methyl ether, but usually when we have the same alkyl group, we're going to use prefixes. So what we're going to call this instead is dimethyl ether. So let's look at aldehydes. You might have heard of formaldehyde. It's a very popular aldehyde used in the preservation of living specimens. So the example that they give us here on the Regents is propanal, and so we know the prefix prop means 3 carbons, and the suffix al means that it's an aldehyde. So the last carbon has this double bonded O and hydrogen. So that's really what we're going to be looking for, is this double bonded oxygen attached to a carbon that has a hydrogen. So let's look at an example. So here we have an example. We can see that we have the aldehyde group circled here. And so what we need is we never need a number for an aldehyde. And we know that because in the example in reference table R, there's no number. So we're just going to mirror it. We're going to adjust our prefix. Instead of prop, we'll count our carbons. There are 4 carbons, so we're going to change our prefix to bute. So this is called butanal. Now let's look at the ketones. Ketones also have that double bonded O on a carbon, but you can see that it's included within the chain. So the name and example on reference table R is 2-pentanone. So what I'll do is we'll start with the pent, and we'll have 5 continuous carbons. The ONE tells us that we need this double bonded oxygen to be attached to a carbon that's in the middle. So these R groups could be any other hydrocarbon, and the 2 gives us the location of that special O. It has to be on the second carbon from the end. So let's look at this example. So we're going to name this example. We can see that we have this special double bonded O, and it is located at position number 2 in my carbon chain. So I'm going to also call this 2, but my carbon chain has just 4 carbons. So this is 2-butanone. Now esters are, again, these interrupted chains. So you can see that there's an included oxygen that interrupts the carbon chain, but one of the carbon chains has this double bonded O. So the Regents example is methyl, meaning 1 carbon, propanoate, which prop means 3 carbons. So when I look at this structure, I can see that I have a single carbon group that I'm calling methyl, and then I can see the 3 carbon group also has that double bonded O that gives it the inoate name for propanoate. So let's look at another example, see if we can use this pattern for another ester. So here we have an ester. You can see it here, but we'll need to look at what our 2 carbon chains are. So the chain to the left is 3 carbons long, giving it the prefix prop, and the chain to the right has 2 carbons, giving it the prefix eth. But this double bonded O is on the 3 carbon chain. So that double bonded O, the inoate, is prop. So this must be called ethyl propanoate. So amines have nitrogen included in the carbon structure. And so the Regents example gives us 1 propanamine. So prop means 3 carbons, and amine means we have the nitrogen, and the number 1 means it's hanging off the first carbon in the chain. So let's see if we can apply this pattern that we see here on our reference table to a different example. So here in this example, we have the nitrogen on the end, and so we know that it is attached to the first carbon in the chain. So we'll adjust the prefix here. So this is called 1-ethanamine. Amides are the last and final structure we're going to look at today. Again, we're just going to take a minute to look at reference table R and see how we can adjust it for a different example. So here we have the amide group. The amide group includes the nitrogen attached to a carbon that has that double bonded O structure. And so their example says propanamide. So what we're going to do is we're going to have 3 carbons for prop and then our amide group. So let's look at another amide group. So first we find the amide group, and then we're going to adjust our carbon chain length. So there are 4 carbons here. So that prefix is but. So this is called butanamide. So by now you should be able to identify functional groups using reference table R as a guide and name any compound containing these functional groups, also known as a substituted hydrocarbon. So remember, we're not memorizing, we're just using examples in our reference table to guide us. So I hope you've taken really good notes, complete your homework, and I'll see you soon in class.